an overview of where we've been, where we're at, and where we're going. After the discussions we've had since terminating the Gresham-Smith contract, I can't be any more solid in my feeling on we made the right decision. So I think the presentation that Ms. Lindsay is going to provide is going to really help us get the project back on track and get to the finish line. So without further ado, Rebecca.
Just before Rebecca starts off, could you give us some anchors, mental anchors on what we're trying to be listening to and stuff?
So, and it's really going to be highlighted in the presentation, but remember, the overall objective of this project was to get a modest means of entry for a sewer project that is not going to be so burdensome on the current ratepayers and be so debt intensive that it puts us kind of behind the eight ball. So that was the intent from
All right, I
the
want to
beginning.
say that again. I want everybody to, this is really critical in where we're trying to go. We could do it a lot of different ways. We're picking out a very specific method that we're going to try to use here. So one more time.
So a very modest means of entry for sewer that won't be so burdensome on the existing ratepayers.
So we are not at this point talking about $120 million sewer plant. We're not talking, or multiple $120 million sewer plants. We're not interested in that concept. We're interested in something that is much more modest as we step into sewer. We haven't done this before. We're going to step into it. So this is baby step in there. All right, with that, you've got it, young lady.
Good morning, everyone. Thank you so much for having me back.
Good morning.
So throughout this, I'm hoping for some
Does she need to
action.
stay behind the mic? I'm sorry. Yeah.
Hopefully, all right, that's all right. Hoping for your feedback as we move forward in this, so please speak up at any time. I hope that this is going to be.
Still can't hear you.
Still not? All right, can I turn this up?
Just, he's
Yep.
going to.
All right, I'll get up on it. Okay, so we've titled this the Now and Next Workshop. Take a look back at what you've done so far, kind of where that puts you, and make sure you understand where you are and the implications of the decisions that you make on moving forward. Oh. Whoop. Oh, man, this thing is, you are not kidding. Whoa.
Boy, this is a fast
Oh,
presentation.
my gosh.
Done.
All right.
All right, we're ready to
I'm going to be very
adjourn. Oh, no.
careful with this thing. I'm just going to set it down. All right. So I'd like to start by reintroducing the team, which is more than just me, and talk about the interpretation and additions to the scope. Went through and really just knowing you better and knowing the project better, made some scope additions that I hope you'll be happy with. And ultimately, if nothing else, I want to walk away from this workshop making sure that you have total confidence in how you're moving forward. And if you don't, let's talk about it and make it right. We'll get it fixed. So we'll review this stated objective that Joseph just reiterated for us. Talk about where you are now, and a reflection on where you've left off with what that means in terms of the viability of this project and practicality and the cost implications. Now, I've done some very, very high-level back-of-napkin numbers, no professional estimating, but I want to give you a picture in this workshop about where your numbers might be sending you, so we can adjust our trajectory if needed. We'll talk about some right-size options, modest means of entry, and a couple of new creative ideas for that, and then summarize the proposed next steps. Okay. The team. So we're all 20-plus year people, so I'll be leading the project as lead engineer and your manager. Tony Garcia, next to me, worked with him for many, many years. He's the best GIS consultant. He's a very senior GIS professional, and he'll be helping me with understanding topographies, creating maps, and delineating links and distances that I'll need for the calculations. David, next to him, David Gibson, also worked with him many years. He's a 30-plus year estimator. He kind of looks like an estimator. He started out in construction, but he's been doing estimating, scheduling, project controls for the last 30 years. He's exceptional. And then Carrie Dial, local, works with another small consulting firm at Moonlights, and Kerry's interesting. He's got some relevant experience in small wastewater systems, and he's also a Class 1 licensed wastewater operator, which is the highest class. So I think his input will be invaluable. Restating the study objective, kind of reiterating what Joseph had just said. It's to provide the authority with a vision for the most accessible means of entry into public sewer service within each target area to inform your next steps. So this is supposed to be that 30,000-foot view. Again, we're looking at roughly a 20-year planning horizon. And the intention of this study was not to figure out a funding mechanism, cost of service. That's the next step. But we certainly want to make decisions in this study that we have a level of confidence that the finances are going to make sense. Any questions or comments so far?
This is finally going the right direction.
Thank you so much. Well, some of my slides may scare you, but we'll get there.
Okay.
All right. Scope summary. I want to revisit what you've done and some tweaks that I've made to the scope. And this is, regardless of what is executed, this is open for discussion if you have comment. So the original scope included project management, the 4 target area workshops, which I participated in. I thought those were great. And then really ended with the sewer flow projections, and you received a tech memo. We'll pick up from there. There was a little bit of effort built to the treatment alternatives assessment and to the study document itself. In between there was a screening and ranking assessment where the intent was to get feedback on some cost and non-cost factors. One observation about this is that it really wasn't interactive, it really wasn't workshop intensive, and having gotten to know you better, I think that's extremely important. So these are the proposed tasks, and I elected to try to adhere to the numbering that was in your prior task order just for continuity. So same project management data review, just engaging the new team, getting everybody up to speed. Added a task to replace the old number 1, which is a Metro District meeting, which Joseph and I actually conducted. There's a lot of institutional knowledge within ARC and the Metro District, and folks that have lessons learned from, granted that you're not in the Metro District, but these folks have lessons learned from seeing utilities grow and get into the sewer business. And so there's also a lot of knowledge there in terms of the future of regulations and watershed protection and interbasin transfers, that sort of thing. So had that meeting. Next, with the flow projections, that task was essentially complete. You received that tech memorandum. We are going to talk about that in this workshop. So that added task there under 2 is this now and next workshop, as I've called it. With the IJA evaluation, there were 4 meetings planned. We added 1 just because we identified a 5th utility that might be worth sitting down with. With the conveyance concept, this is broken down now into tasks 4A and 4B. Conveyance concept, want to add the option here to talk about potential for using low pressure sewer in lieu of conventional sewer. And again, we'll talk about that in this workshop and see if that's something that you wish to entertain. Decentralized treatment. At the conclusion of both of those 04 tasks, looking at conveyance, looking at treatment, I've proposed adding another workshop. I think that's a really important point to stop and see where you are. Did you have a question? No? Okay. And then task 5 was essentially a revamping of the how that task would be executed with the same deliverable. Previously, the intention was to conduct a big workshop and get feedback to rank all of the cost and non-cost. I think that's asking a little bit too much with a room full of people and different ideas. So the changed approach that I propose is to provide you with a technical memorandum that, having solicited some feedback from you on some non-cost factors, because there may be factors that are on your minds that I won't think of. So I solicit input on that, and then we compile a technical memorandum that goes through the analysis of the alternatives and provides you with some insight on the pros and the cons, the cost implications, both capital and operating cost. Allows you to read that and digest it, and then provides you with a matrix, a scoring matrix, that you can individually put your feedback. I will assimilate that feedback and then come and present the assimilated results to you in a workshop, which we can then, discuss, particularly if there's deviations, if people came to different conclusions, and hopefully at the conclusion of that, we would have that prioritization workshop and complete the ranking assessment. And then the draft feasibility study would essentially be taking that tech memo and then concluding it, identifying what was selected, and also adding to it the recommendations on the next steps, where you need to go from here, and mapping out that journey, that roadmap for you. Any questions? Okay, so we get into where you left off. You've received a flow projections memo from the previous firm, and it walked through a very logical methodology and kind of a textbook methodology in calculating sewer flows. At the very back page of that TEP memo was a summary table, large summary table. And that table presented each of your area boundaries. And if you remember, there were generally a couple. There would be an overlay, like a smaller boundary, and then in several cases an expanded boundary. So flows were totaled up with these 4 columns here: current demand, current and planned, 20-year, and full build out. And what I've chosen to do here, instead of presenting that entire table, I've picked out just 3 of those scenarios, and I'll explain why. First, I want to point out that current demand here on the left is that's the lowest projection that you were given. And I want to be clear that it's a bit of a misnomer, because that current demand, those are current septic users. There's no reason to believe that when you put pipe in the ground and put in a treatment system, that all of those septic users are going to connect to your system. So I want to be clear starting out that current demand number is a very ambitious number. So there's certainly some planned developments, but comparing between the two, looking at the difference maybe between current and planned, with some small amount of current being anticipated to tap on. So
excuse me, Rebecca. So this is the report that we had was presented, and that number for current demand is based on all households or all residences within the county.
Everything that is already developed within that area. So for this first example, AKB overlay, the prior firm looked at everything that was existing within that corridor, within that boundary, and included that number in that 0.189 MGD peak flow.
So in this process with you, will we be going back and correcting these numbers to something? Because I think it's valid that we cannot make the assumption that someone who is on septic is going to even want to. Why would you if you're not having a problem? So those numbers are totally irrelevant or...
They're maybe aspirational, okay?
Yeah.
I don't think I don't think this is bad. I don't think it just doesn't help you. What I'm scared about more than anything, and from the workshops, y'all may remember I kept saying, make that boundary really small. It's this is going to get expensive fast, and the other utilities. It has happened many times that utilities build infrastructure, and day one it comes online, and there's a bucket of wastewater flow. So years and years later, after you've fired me and chosen a new engineer, then in 35 years you'll see the wisdom in having built the infrastructure. But I'd rather not get to that point and lead you in a more sensible direction.
Okay.
So yes, and I do in here have a strategy of how I would maybe suggest you think about it and approach it, which isn't exactly based on new calculations, because what would be the basis for new calculations? So I'll walk you through that.
Okay.
What jumps out at you is the Arthur Bolton numbers.
Yeah.
Well, right. So that's the reason I chose AKB to show. That's one of the reasons. So I chose to shortlist these kind of three. The top category is AKB overlay, so that's the small boundary. And the interesting thing about that, I went through the math of the whole table, and I divided full build out, that number on the right, 1.438, divided by the current demand number on the far left, 0.189, and that multiple in that scenario is like 7.6. It's a big multiple. It's the biggest multiple of any scenario that you had. So just on that basis, just on even that very small area, there was a tremendous, growth trajectory between what they are saying is the baseline, that current demand, versus where maybe you think you want to go. And then to compound it, you look at the next scenario, which is AKB expanded. Look at that 6.442. Now, 6.442 million gallons per day is more than City of Griffin's 3 wastewater plants combined. If that helps you understand the sense of how aspirational that number is, and then if you look at 6.442 MGD versus the smallest scenario, 0.189 for AKB, that's like a 34 times multiple. That's a huge. So I want to point out that this may not be rational or viable for, and certainly not technically viable for any sort of sizing for expansion. And then the reason I chose Tri-County, this being the overlay, is of all the numbers in the report, this was the smallest number. So let's start small. So we're going to revisit those numbers. The AKB overlay, which is 189,000 gallons per day, that's peak flow. That's based on a multiple of 4, peaking factor of 4, I should say. So which is not unreasonable. They took that total gallons per day, multiplied it by 4, and then the 31,000 gallons per day for Tri-County overlay. So remember those numbers, and we'll come back to them in just a second. But I wanted to diverge briefly and hit on treatment options. I have a recommendation, but I want you to understand what the options are, and you can direct me to go somewhere else if you'd like. What I'm referring to is the basic land application, or LAS. So there are. This is essentially a way to treat the water to a not super high standard, but to treat the water, and then you essentially dispose of it on the ground or in the ground. It requires land to do that, and you can do it. You can do it subsurface, which you don't have to then add disinfectant, but it's not often done. It's more expensive. It's hard to see where it's going and maintain. If any of you've ever had, especially in this drip option, if anybody that's had a drip irrigation system and something breaks and trying to find out where it's broken, it's pretty hard to maintain. So the spray field option is by far the most common. These require a significant amount of land, and the amount is a wild guess right now because we don't know your perk rate. And give some 4 instances. There's a 100,000 gallon a day system in Walnut Grove that's only using 50 acres. But then Oconee County has gone through this and has a 400,000 gallon a day system. It's over 350 acres, and there's buffers required and that sort of thing. But that spray field option is the most common. So you'd have a pattern of nozzles, and you'd spray and you would rotate. You would rotate around different areas in your LES site, and what you can apply depends on sort of the uptake rate of your soil as well as the crops that you plant there. So this can be you can achieve the level of treatment you need through a pond lagoon type system, which is going to be a very large footprint, modular or bolt up. Generally what we've been talking about, much smaller footprint, better level of treatment, and really more adaptable to whatever direction you may go in the future. And then conventional concrete, which I generally would not recommend doing. I would not recommend putting concrete in the ground or on the ground until you have are really confident that that's going to be permanent infrastructure and is expandable to what you need. So these modular plants, rough rule of thumb is you need about 50,000 gallons a day to make them economically viable. But they can get quite large. Really, there's no limit. But once you get into a very, very large system, that's generally when it's more permanent and you're putting in concrete. So that's the general land application. As you proceed, Georgia EPD, they'll require that you write an anti-degradation report, this analysis. And in essence, EPD is going to say you have to do land application unless you can prove to us that it is not viable. And then we'll think about giving you a stream discharge, an NPDES discharge. And I recognize that EPD's culture on that topic has varied over the years, and certainly in consideration of different basins. But that is the textbook approach. Right now, that is the, and I will say actually, Oconee County is a great example. They wrote EPD, they did their anti-deg, years ago. They had this 400,000 gallon a day LAS, and they said, it's $15,000 an acre out here. We can't afford to do this. And EPD said, that's not our problem. Money's not a matter to us. If it's technically viable, you have to do this LES. So the next tier, still in the category of land application, would really be getting the water to a reuse level, which means that you can have human contact. You can put it on a golf course. Some places find this option attractive. It's certainly a much more expensive plant, much more expensive O&M, and furthermore, and I think that if you look at Sun City, Peachtree, and some other applications, the state does not want to incentivize irrigation. So the pitfalls of this have been that the users, the irrigators, are not. They're generally getting low cost or free water, and also they don't want to take it when they don't need it. So it's your problem in the winter. You got to have ponds to put it in, and that would, unless there's a driver for that you want to express to me, I would not recommend thinking about a reuse application for this. Then the last category would be then the NPDES permit. So this is a stream discharge and requires achieving a very high level of treatment and also a much higher O&M cost, if only because of labor. So an example of a roughly 100,000 gallon per day basic LAS is going to be $150,000 a year in power, labor, some sampling. They aren't manned. You generally have somebody do a drive-by once a day. You can hire a Class 1 operator as a consultant for $3,000 to $7,000 a month, or at most to operate, or just to sign off on monthly reports and sampling. Whereas with an NPDES permit, you're going to need probably 3 Class 3 operators and 1 Class 1 operator. It'll be $400,000 a year in labor alone, not to mention all the other costs. Saying that, considering the importance of cost, and also recognizing that EPD's disposition is that you have to do LAS unless it is not viable for some reason. I think that my recommendation would be that you plan to eventually have that stream discharge, but make the baseline concept the basic LAS. And at what flow that might occur is somewhat up to the state of mind of Georgia EPD at the time that you apply. So I intend to have some conversations with some of their modelers and the folks that are making these decisions and get at least a verbal. But we may be talking about 500,000 gallons per day. Don't know. But for a more modest means of entry, restating that objective, your basic land application spray field is going to be your best bet. Yes, sir.
I have to weigh in here. Because I have a whole different view. I understand land application, but I'm gonna make these points. There's a fly in the ointment here. First off, the city's land application out at Shoal Creek is under high stress and pressure from the EPD to convert to a stream discharge, nitrification problems and other things. So EPD is on them very seriously to convert to a stream application. Secondly, I made a presentation to the Upper Flint River Water Council a few months ago. Joseph and I were there on that very subject. And there's a powerful force on the Upper Flint River Council, which is Gordon Rogers, head of the Flint River Keepers, and also Ben, what's his name, who's head of the American Rivers. And they are on, I don't know how to put this, but they're very serious about putting river water back into the Flint because it's the most highly stressed river in. And if you start talking land application, they're going to be up in arms quickly because they want that water back into Flint because it's overused right now. And they want the city to put it back into the Flint and get off the land application system. And my presentation was those numbers for the Shoal Creek, put it back in the river, and Gordon Rogers and the River Keepers said, if you'll convert it to a stream discharge, we're gonna help you find money and we might help fund it. That comes straight from the Upper Flint. So land application in a small beginner might fly, but the Upper Flint water keepers are really upset about all the septic tanks we have and the lack of water going back to the Flint River, and they want to change that. So you're gonna run into some serious opposition if it does not go back to the Flint. And both the Shoal Creek and the Potato Creek go to the Flint. So I guess I'm not trying to tell you where to go, but I'm saying those plants, Shoal Creek doesn't go back to the Flint yet, but that is a smart just been started. The city is working to expand it and convert it and put it back in the Flint to keep the river keepers and EPD happy.
Right.
So partnering with them for get the water back to Flint and off the land application would be a lot easier sell for that group. And the state water councils have power these days. So I just throw that out that you got to deal with those folks.
It's,
They can be for you, against you.
well, if, we're still gonna explore the IJA option. So in the event that it can work out contractually, financially to convey water to Griffin, which would then fall under their NPDES permit when they convert to a stream discharge, that could be a great solution. In the interim, when we're talking about a small flow, let's say we're talking about 100,000 gallons per day, that at that number, financially, it's going to be so much more expensive for you to, for the upfront capital, for the O&M, for a stream
I understand
discharge.
that.
And so that's why I'm saying that there's some sort of tipping point. And I suspect that number is going to be somewhere in the 500,000 gallon per day range. And that's all subject to, again, EPD's disposition. As I said in the beginning, their permitting language says, we want you to do LAS unless you can prove to us it's not viable. But I understand that there are other factors going on with the Flint. So we intend to have conversations with EPD to figure out what that tipping point is, what that flow might be. But I do think, and I'm open to this changing as we go forward. I think as a baseline, if we believe that EPD's not going to make us do a stream discharge, if we're still talking about a relatively low flow, then your best cost option is going to be the basic LES.
Yeah,
So,
I'm not trying to tell you which way to go, what to look at, that's your job, but I'm just saying that force is out there, and you probably need to talk to some of those folks to get their opinion, because they were very strongly opinionated when I was there,
yeah.
about where it goes and not whether it goes to Flint or not, so you just be aware.
Understood. I could build the concept of a plant around, and your O&M costs, capital and O&M, around a plant that would achieve anticipated stream discharge limits, which we are somewhat maybe of a guess at this point. And then would have to include piping and pumping to get it to a discharge or site it there. It's gonna increase your baseline cost for, that, and depending on what target
Again,
area.
I'm not trying to tell you what to do, what
Yeah.
to recommend, I'm just warning you that
Yeah,
that's out there,
okay.
for what it's worth.
Perhaps we have that later workshop that I mentioned where we revisit after we have a treatment concept and a conveyance concept. And certainly that'll be based on, a flow. And by that point, with some further conversations with EPD, have at least a verbal on sort of what that flow tipping point is, and also what the treatment requirements might be for a point discharge. So we can revisit this topic at that time, and if it's looking like, number one, the EPD will allow a stream discharge for the type of flow we're talking about, the level of flow. And if it looks like, if there is a financial incentive that might offset,
That's what
then-
caught my attention when Gordon Rogers says, if you'll get the water back to the Flint, we've got money, we'll help you with it. And that,
Okay.
when somebody says that, I listen.
Thank
Yeah,
you.
other people's
And
money,
it might-
OPM.
It might be talk, I don't know, but it's worth paying attention to.
Okay, let's move on. Thank
Okay.
you.
Yeah.
Okay, I don't know what IHJ is.
Oh,
Interjurisdictional.
interjurisdictional agreement. So it's just, we're having initial conversations with, Hampton, Sonoya, Butts County, 5 total, Griffin, Sun City, Peachtree, those are the 5, to talk about if a partnership in sewer, it might even be, if they're interested in having the conversation, if so, what capacity they may have, what capacity they may need, and what a capital investment might look like, and then a usage cost. So, no guarantees on what may come out of that process, but at least at the end of this project, I think you'll have an understanding of whether these partnerships are viable to get, into the meat of the terms of a potential agreement, based on what capital may exist or be available, how far you'd have to pump to get it there, that sort of thing, so. Okay, all right, so remember those numbers we talked about before. It was 189,000 for AKB, small area, and I've circled recommendation here. So a closer look at AKB. The green boundary was the one, based on your feedback, that was the expanded, the big picture goal. And then the purple there was the tighter overlay. And I just drew a blue line along AKB, just along the corridor. You'll note I did not branch out from that main pipe, if you will. I want to talk about what might go into a project like that. So that minimum demand from the prior report, which was called the current demand or flow, was 189,000 gallons per day. But we've discussed that that's not a realistic number certainly not for day one. So I thought, let's look at a concept of 100,000 gallons per day. It's just a starting point. And I put together some very, very high level costs. These costs do not include some very expensive things, design, permitting, supporting survey geotech, any kind of legal associated with land acquisition or land acquisition itself for whether it's easement for pipeline or plant, pump station property. As I stated, The pipe length that I sketched out there, that blue line, is just along AKB. It's not a network from there. And the plant concept is based on the basic LES. So that length is 34,000 linear feet approximately. If you look at whether it's 8-inch gravity sewer or force main, really irrespective of material cost, PVC and HDPE are, and ductile iron are pretty similar right now, including the pertinences and clearing. So we're looking at over $25 million for that length of pipe alone. This zone, this target area, has a low point and will require a pump station somewhere to get flow from one side to the other. So a small package pump station, roughly $1.5 million. The modular plant, City of Mansfield recently got a proposal for a 100,000 gallon per day system. So took theirs and built on it, had some exclusions, and plugged in $3 million. And then you've got the LES pond and spray field. There was a recent project for a 100,000 gallon per day spray field, and it was 2. So I plugged in 2.5 there. So that's a total of $32.5 million for this, what I would call a base concept for AKB. To put that into context, and I'm going to use throughout this presentation just residential, even though I understand that most of your development that you're planning is not residential, but it's an easy estimator. So if we talk about a residential context at 200 gallons per day per household, that 100,000 gallon per day concept would cost each homeowner effectively $65,000 per home, not including the exclusions, the very big exclusions that I noted here.
65,000 per home,
Right,
so
roughly.
32.5 and pipe and equipment and real estate. Basically, I guess well, no, your cost is just the equipment for the pond and the spray field, right? So there's no dirt being purchased in that $2.5 million yet.
Yeah.
Okay, so we're about 75 million turnkey, 100?
I would hope you'd be below 100. I mean, so
Just
your
75,
land
65?
costs are probably, what, 8,000 an acre is what I was
Around
thinking.
here?
Yeah.
Ah.
Well, it's going to be around, and you might even be able to get some land donated
Large
or,
tracts of land been bought by developers
Yeah.
already, so,
yeah.
But- Question about this. So we're just talking about the AKB small frame.
That's right.
Okay, the AKB overlay has a requirement that you cannot do anything for 500 feet either side of the road? So that's the right of way, right? I'm looking at Steve,
That's correct, yes, ma'am.
That's
So,
privately owned.
but I'm just saying there's a potential for us to be able to
Work
access.
inside the right of way through GDOT's.
Right.
but you still have to buy the land for the spray field.
Yes.
Depending on what the land perks at, how many acres you're gonna need.
Correct.
But it wouldn't necessarily be that, would that be GDOT or would that just be,
The land app would be ours, so we would have to purchase that land, but working inside of their right of way would
Like
not
the sewer
cost
line.
us anything initially.
okay.
So what you're telling us is that even the limited look at AKB is mind-blowing numbers.
That's right.
I got that. Okay.
So
What's
let's,
plan B?
are we going to go home now? And so I have a few suggestions to think about. I don't want to leave you despairing. So,
We're not despairing.
all right, I felt like this was important to look at because, again, the numbers in your prior report were so ambitious, and I don't want to get you to the end of this study with something that makes absolutely no financial sense. So I
And
just
for
wanted to.
us, there would be very little residential application during the short plan out AKB. So
You're
all
right.
of those, and I'm saying that because so many industrial customers want us to help provide sewer. So, I mean, that would be the only possibility for us getting customers in that initial area.
I think what y'all was just voting on was warehouses, right? Okay, there's not gonna be a lot of flow coming out of it.
No, but they do, because of the terrain, they do need the ability to not have to have a septic tank. I mean, because there's so many streams over in that area.
So you're going to go to another area quickly? Is that what we're saying?
All right, Tri-County. This was the smallest one, right?
Yes.
So again, you've got the Pepto-Bismol big area, but if we just talk about the overlay corridor in yellow, forgive again my artwork, but I drew two little pipe legs there, kind of following major roads like you might. A few thousand feet, 2 or 3 on that little east-west leg, and then maybe 7,000 north-south, so that's about 10,000 feet. The minimum demand and the calculating the report had been 31,000 as, again, current demand. But let's stick with the 100,000 because when you, there's equalities of scale in building a plant. You can build a plant twice the size of what you need to be able to grow into it a lot more cost effectively than, it's not times 2 to double the size of the plant, I'll say that. So line items here, that length totaled up to 9930. Again, assuming 8-inch gravity sewer, $7.5 million in pipe cost here. In this particular zone, you shouldn't need a pump station. Same number for the modular plant, same number for the pond and spray field, and we come up to about 13 million, which is still a big number, but it's a fraction of what we were talking about for AKB. And I did want to point out that still, pipe is a large part of this cost. It was a very large part, 80% or so of the AKB, and still 60% of this one. So we're getting a little closer, maybe, to a number that might be manageable when you divide it into the number of customers that are really have real interest in connecting soon. Still concerned about that pipeline number, and I thought you might be too. So I wanted to introduce another option for you to consider. Anybody familiar with low pressure sewer? A little bit? Okay. Low pressure sewer is, it's been done for a long time, very successfully. It's not widely used in Georgia. There's probably a dozen folks doing it. It's widely used in East Tennessee and Florida, and for 2 very different reasons. And Florida is really flat, and East Tennessee is really hilly. So for both reasons, it's used a lot in those places. It is an alternative to conventional gravity sewer, but it can be used in combination. So you could have, and often utilities do have a, some sort of a conventional gravity sewer. We're talking, manholes and pipes that slope on grade, and everything is under gravity. In the concept of a low pressure sewer, everything's under pressure. And the operating pressure is just going to depend on how many connections you have and the head conditions of your configuration. It could be as much, it's low pressure, but it could be as high as maybe 80 PSI, which isn't particularly low, but you want to keep it relatively low because that keeps down some of the maintenance. So every customer, if you were to imagine a subdivision, every one of those houses is going to have its own little pump station, little grinder pump station. So it's a pump that grinds and chops, and because it's chopping flow into little bits, you can use smaller pipes. And again, because it's under pressure, you can use smaller pipes. So the pipe can be laid more shallow. It can be, you just got to get it below the frost line, 3-something feet, and you can go, it doesn't mind going uphill. So you don't have all the constraints of gravity sewer where you really have to lay on grade, and gravity sewer can get deep in places because you are having to maintain that gradient. So the maximum diameter of any LPS system is going to be 8 inches, at least known to date, whereas that would be the minimum diameter in your conventional gravity sewer generally. One concern that's eliminated almost entirely with low pressure sewer is inflow and infiltration. I&I, which is Gravity sewer pipes, not under pressure. It's real easy, you know, you get high water tables, you're next to a creek, or, you know, so you get water coming into your collection system, and that can, number one, it's a tremendous maintenance expense. Long-term, you know, utilities are driving camera trucks up the line, and also you're trying to line your pipes and inspect and smoke test and dye test and and then you're treating this flow, all this extra flow that's coming in, you have to treat. So inflow and infiltration is a serious concern, especially for aging utilities. It would not be a concern here. So remember in that table, that summary of flow table, I mentioned that there was a peaking factor of 4. You basically have a peaking factor of 1, and the only peaks you're going to have are really your diurnal peaks of when people are taking their most showers in the morning, that type of thing, or whatever, you know, the commercial curve might be. So there's an advantage. That's a major point. There's an advantage in terms of the flow because I does not have to be included. I want to note that if you choose to go this route, at some point down the road, you'll give significant thought to policies. It's an entirely different set of policies when you're implementing, and that is what can make or break the success of a low pressure system. If you don't have good policies in place, it'll be problematic. There's discussion of ownership, and every one of these homes or businesses has one of these grinder pump stations, and you got to make sure that they're maintaining it. You can't necessarily trust the property owner to do that. So there are ways, there are very proven ways to make sure that maintenance is paid for and these systems are maintained. Large systems, there are systems that are a couple thousand connections, and that's starting to kind of push the limit of how big a network might be. So, and then typically the per station flow would not be more than 10,000 gallons per day. So if you had a large facility in terms of it's very expansive, or large in terms of flow, you might have a couple of these pump stations. So if your long-term vision is a lot more than 1,000 plus, certainly 2,000 plus connections per day, low pressure sewer might not be the direction that you want to be thinking. On the other hand, if the flows we're talking about do meet your needs and maybe even provide some incentive for restricting growth beyond those needs, this could be a very attractive option and a much more affordable option.
Would it be possible to convert someone with a septic tank over to a system like this?
Yes. Absolutely.
Yeah, it's flowing.
I did some building in a place with this very system. It's scary though that when people find they have a grinder and they're going away and they have the responsibility for it, but I'll have to say that, again, this goes to Shoal Creek, which unless something's changed very recently, the city's actively working to increase and change the Shoal Creek to handle a lot more capacity. This little area doesn't seem to me like you could compete with your own sewer plant when you can put it into a big plant. Just getting it to them, if they convert and have all this capacity, when you do your IJA discussions, I think ultimately, I'm not trying to promote the city's business, but it'd be a lot easier to get this small amount to their new plant if they have the capacity and let them worry about it than try to run their own plant.
Wasn't there one time something mentioned about this possibly being able to connect to Potato Creek?
You can pump it over to Potato Creek too, but it naturally goes to, if I'm not mistaken, to Shoal Creek.
So,
But they were using, so Shoal Creek was full, so they had an alternative plan to pump it over the hill over to Potato Creek, but if I'm not mistaken, it does drain to Shoal Creek.
so yeah, so you're, so again, this concept of piping is really, in my mind, totally independent of, you've got a question in terms of treatment. Do you do a decentralized treatment option, or do you implement an IJA if you have a receptive party?
So
both
you're
of those are
saying
on the
that
table.
low pressure connections, you can pump them, you don't have to have your own plant, you can pump them anywhere you want. It's the collection pumping system is sort of independent of the treatment.
Exactly. So, we're going to look at decentralized treatment. We're going to look at those IJs. We'll identify what is most viable. Separately, this is an entirely different discussion. The only way it relates at all is that low-pressure sewer should give you should have less flow because you don't have to worry about those peaking factors in I&I ultimately. And then also, if we're talking about getting some distance away further to get to a discharge point with Griffin or any IJ, your piping costs could be lower and you could go uphill easier. So there, other than that, though, the two topics are very distinct.
Okay.
So we could technically or theoretically convey cheaper
Yes.
going this route.
You want to look at it?
Yes, I do.
All right, let's look at Tri-County.
Okay.
I was thinking of a neighborhood right now.
Well, I
So-
think this area is mostly commercial, and business owners probably are not as freaked about having a grinder in their front yard as homeowners are, so they,
Well, if you put
it's a cost of
grinder-
business.
If you put the grinder in the existing septic tank though,
Well, I understand, I've been down that route, but still homeowners are more freaked than business people.
I had one growing up. It wasn't actually a low-pressure sewer, but our septic tank wasn't built quite low enough. So we had a pump in our basement, and it was bad news when it rained, and that hole filled up with water. But other than that, you just didn't use the downstairs bathroom. But other than that, you didn't know it was there. And so again, these and if you decide you want to get serious about considering this, there's tons of material on best management practices, policies, case studies, utility videos, utilities giving their testimonies about what they've experienced. And that's a whole nother, again, policy-driven decision. But just in terms of logistics and cost here, so we get to reduce that peaking factor so that 7704, originally it was times 4, that was at 31,000 gallons per day. But if you assume 200 gallons per day per connection, which again, I'm using residential because it's easier, it's just a baseline. We'll fall in a range of 31 to 50 units, pump station, grinder units. And that's the way these systems are sized, is you figure, how many units do you have? And based on that, there's data on how many will be expected to be operating simultaneously. And you size your system to accommodate that flow and maintain a certain velocity in the pipe, or a range of velocity in the pipe. So this would allow you to, again, conceptually, this is all very high level, reduce your sewer diameter from that 8-inch before to 3-inch. 10,000 feet, same number. Now of that 3-inch low pressure, we're talking about $1 million. That gets your total to 7-ish, again, very high level conceptual. Now recognize that I have maybe hand waved the cost of the grinder units. 20,000 is probably a very conservative number, and often it's like 7,000 or 8,000. But it depends on how many you're doing, and maybe the distance from the customer to the main pipe. And but these
it's better than $68,000 per house.
well, these once you implement a policy, it'll be the developer, the homeowner, that cost is would be part of their build generally. So you were interested in a modest means of entry.
Good. That's a good idea.
So I think that, and I'm kind of towards the end here and hoping for some just open dialogue. So key questions to consider next as we move into next territory. Looking at that 20-year horizon, weighing your capital and long-term O&M, temporary and permanent. So there's making the best financial decision, but recognizing that it's planned for 20 years, which is essentially the end of life for most equipment, that sort of thing. So, to the extent you can give me feedback on, where you might want to invest more capital. For example, if we're talking about gravity sewer versus low pressure sewer, if you really feel like those big flow numbers in any particular area, and you can have a different opinion for different areas. You may say, hey, Tri-County, low pressure sewer sounds great, but AKB, we want to grow big. Let's keep it the conventional. We can do whatever you desire doing, but feedback on making decisions about where you want to maybe invest more in capital, and with the extent of being able to grow. Preference for restricting or compartmentalizing growth. Again, this is how expandable do you need or want your system to be. And again, looking back at that, so if we think about a low pressure sewer system, the biggest pipe diameter used, I wouldn't want to test that, is 8 inches. So if you figure you've got a 3 foot per second velocity in an 8-inch pipe, ultimately you can get to 500,000 gallons per day, which is kind of the number we were discussing as being maybe a tipping point, and also it's a pretty substantial size getting to that volume. So other questions regarding upfront cost. My feeling has been that you're most likely to be successful if we can start you small, somewhere that you can get revenue quickly and confidently. Start making money, figure some things out, adapt, and then grow. But make sure that you have, and I'd love to be able to figure out a financially viable model in all 4 areas, but even if you can get there in just one, because we're ultimately going to prioritize and say this is the best starting point. This is what makes the most sense. So my hope is to get there and to understand what your appetite is for those upfront dollar values. And again, this project is not about figuring out how to fund that or any kind of cost model, but we can be pretty realistic about what numbers look big and what numbers look comfortable based on the number of customers that you expect to have in the near future. So this last bullet point, the 500 home equivalent, again, just talking about houses because that's easy math. If we figure a couple hundred gallons per day, that 500 homes would put you at that 100,000 gallon per day plant concept that we were discussing. So it's and even I think I mentioned that 50,000 gallons per day plant is kind of a point at which it starts to make economic sense. So even half of this. So my guidance to your question in the beginning, do we need to redo these flow projections? I think it's more a matter of looking at these areas and getting confident that you can, in the very near term, connect 250 to 500 homes or the equivalent, something like that. That is whichever zone and boundary you believe allows you to do that easiest, that is going to put you in the realm of where your most cost-effective scenario is. So if you think about 250 homes as a minimum, 500 getting you towards that 100,000. And again, the flows do depend on whether we're sizing for low-pressure sewer or conventional. But last slide here, I think, general phasing. This is a thought process phasing. So understand, based on the numbers that I presented, just these high-level numbers, point me in the right direction of how what your investment appetite is for cost per customer or total cost, or areas when we expect we're most likely to get those 250 customers pretty quickly. And then from there, I can revisit those current demands, look at the number of plan connections, and give some thought to your flow at day one. Again, that day one, when you have that bucket of wastewater coming in, making sure that we size infrastructure to operate okay at those ranges. So I'm proposing to kind of work backwards here from, we know that a cost-effective plant is going to be 50,000 gallons per day, 100,000 gallons per day range. Got to get to that number. So I'm thinking the alternate approach is to look at how we achieve that kind of flow. Look at low pressure versus conventional if you wish to. I would say if you're really expecting more than 1,000 customers, certainly more than a couple thousand, that's probably not, low pressure sewer might not be your best long-term option for that. It might get you in the door though. So you could get in the door with low pressure sewer with the understanding that, conventional might be your best bet long-term. And again, for low pressure conventional, if you're expecting very large users, very large flow, more than 10,000 gallons a day, that is testing the limits of some low pressure sewer systems. Then looking last at the treatment and phasing, really big picture, long term, your system falls such that it probably makes sense for you to have a west plant and an east plant, and to get that Flint discharge, the stream discharge. That long term is probably the direction that you need to go. But in the interim, for the flows that we're talking about, the LAS is going to be probably your best bet, and we'll investigate that tipping point to try to make sure that your strategy aligns with what you're doing long term. And that is conclusion for feedback. Yes, sir.
I have a couple of takeaways, but you made me realize that the treatment and the collection system of you are sort of separate decisions. So after you do your IJA discussion with other treatment providers, then you decide whether that's a better treatment option, but you still have to do the, for lack of a better word, the collection system, right? It's sort of separate decisions.
Yes, sir.
So if you do that and you find that there's another sewer system that provide treatment, might be easier to hook on that than build your own plant. But that's kind of I didn't think about those as separate pieces, but I understand what you're saying.
They are. And again, the only way they really overlap is it's tricky for me. If I don't know moving forward whether we're talking about low pressure sewer, which would be a peaking factor of like 1, or if I'm talking about a peaking factor of 4, because the range of flows, it'll be a little bit more challenging to negotiate an IJA, or so. It'll be helpful to me to understand what you feel like you're more interested in certain areas, or what criteria you're kind of looking for. Although, I mean, I'm going to keep eyes wide open going forward, and we can adjust. But yes, and then in terms of if these areas are not close to a discharge point with that receiving sewer, or whoever's it is, that just the piping consideration may come into play, not just from a cost length, but also grade. Are we going to need to pump again and add all that cost? So if you were a long distance from a viable IJA and they had a really great treatment option, they said, come on, we got plenty of capacity, we'll make it cheap, tie in. But they're a good distance away and they're uphill, we may more than ever want to say this is a low pressure sewer scenario for us.
Yeah, the second thing is, I can't speak for the commissioners, but I can speak for myself, and what I think the commissioners have been saying is I hear a lot of word residents thrown in there, but I don't think they're really interested in throwing this county open to widespread development. This is targeted to our industrial commercial quarters primarily, so I'm assuming that they want to target this and not just throw subdivisions up all over the county.
Right.
So the residential thing is the last part of the market. Although there are houses I got that, apartments, but.
So the concept of looking at a number of residences is really just because it's easier to talk about that.
I understand.
Because commercial and industrial, what does that mean? You could have a very low, like you said, a warehouse flow, one bathroom in the back, and very light use, and some commercial users are much more significant. So it's just,
Or a paper mill,
yeah, it's
would pay for the entire plant.
right. So it's just easier to talk about
Okay.
the example of a house and 200.
I understand
yeah.
that. But
Right.
make sure from what I'm hearing
For example, what would, if you were making an equivalency, what would a restaurant equal in houses? Or what would a hotel equal in houses?
So, a hotel. So warehouses, for example, are usually based on the number of square feet in the warehouse. But sometimes we will use like plumbing codes, like we'll find out the number of fixtures.
Right.
But then it can get really tricky if you, because a lot of these are spec buildings, and then you find out that it's an Amazon fulfillment center coming in or something, and it's, restaurants, it would be usually based on the number of seats in the restaurant. And actually, restaurants generally are not tremendous flows. So then if you get a brewery or something,
Right.
Hotels are going to be based on number of rooms. There's extensive tables of, estimates that you can do, but your current projections are based on what is most, I don't want to say likely. Your current projections are based on your current zoning, what is going to be the higher flow that you would expect to occur in that zoning. So I think they're already pretty conservative for, not every case scenario. There's if you get a data center, like Facebook or Microsoft comes in and is, discharging a huge amount of cooling water. I mean, that's a game changer. But I think as an average, the numbers that were projected are conservative and are based on your current zoning. So-
I'll say this, I've developed a restaurant and it depends. Because if it's a carry-out restaurant with plastic and paper packaging, it's one thing. If it's a service restaurant with dishwashing, it's a whole different game.
Right. Right. And that's why I said number of seats is usually the logic.
It's-
Yes, ma'am.
There's no answer to your question.
I know we talked about, basically, in speaking about AKB, we talked about, the potential for the need for sewer along that corridor is generally, in my mind, is generally based on commercial. However, in the instance of, like AKB and High Falls Road, everything that fronts on the AKB side, the back side is in a residence. So if you have someone who, if we were to put sewer down AKB and a building or development went from AKB to High Falls Road, what would stop someone on the other side of High Falls Road from developing housing or apartments? Because I think the ordinance says that if sewer is contiguous to your property,
You must.
yeah, you gotta get it. So the potential for housing on AKB is literally, in some places, a block off from AKB to the neighborhood on the other side. So even though we are talking about AKB, I think we need to be conscientious of there's a lot of land that's undeveloped just on the backside of AKB that is on low-density residential AR1. And if we look at the development that's happening just out Tiemann Road and out behind Sun City, because they have sewer, we have to believe that if we're able to make it available on AKB, there's no reason why everybody else is not gonna wanna develop on that land that's contiguous to it.
You got it.
So,
That's
yes,
That's a really big issue that she's talking about. I spent some time talking to Henry County Commissioner about how they developed. And they said, once we opened sewer up, our entire county changed. We had the same basic, you have to hook on, because that's what they wanted, to be able to get revenue to begin with. And then everybody came. The exact same thing is happening, like she said, up in Tiemann and 155. We took the Sun City plant, and they said there's sewer there, and all of a sudden, thousands of homes have all of a sudden jumped up and said, we want to do this. Now, that's a whole lot different than most of our community, Spalding County, is looking for. We run it down AKB, and if we do the same thing we see that happened up in the northeast corridor, we're talking about a huge change in what our county looks like. As an example, we're going to probably increase our population over the next 2 or 3 years because of the housing, 10%, just up in that northeast corner. We run it down AKB, this will develop into a different county. And you have to think through, yes, economic development is good and all of that stuff, but what do our citizens who live here and have lived here all of their life, what do they like because of the uniqueness of ours? Now, just so everybody understands, the county manager will talk to you about you can't do one without the other. There are 3 parts of it, commercial, industrial, and residential. You have to move in those 3 circles simultaneously. You can't just say, we're only gonna do commercial. When we run it up AKB, if our mind is only commercial, I'm telling you, that won't happen. So get ready for the explosion that will happen if we do that. And is that what, in fact, the residents all around our county want? It is a big decision that I want everybody to think through.
Water only goes to High Falls, doesn't it?
I'm sorry?
Water only goes to High Falls, doesn't it?
Water? No, it's,
Well, it doesn't go up AKP, it goes
I
around.
mean, AKB, it doesn't go all the way to the interstate.
no.
So it's not like we're,
I mean, it's crossing, one of our pipes is actually exposed right now, because the bank's washed away,
But I
but
mean-
it's down there.
So my issue with it is,
We understand what you're saying.
okay, good, thank you.
And I'll have to say, the Tri-County area being contained and mostly already commercially headed sounds to me like a interesting start.
Low pressure sewer sounds wonderful to me.
So these are,
But just know that's the unintended consequence.
So to kind of relieve some.
step to the mic, please. Remember, we're all trying to record this, so we're.
To relieve some concerns, when we talk about confining it into a low-pressure pipe and saying we're gonna take it to a 3-inch, that pipe has some capacity. So inside that pipe, we can range it from 2.5 feet per second all the way up to around 7 or 8. You really don't wanna get that high because of the scour, but there is built-in capacity. But to everyone's concern on this growth, we can put policies in place where if a subdivision wants to tie on and that pipe is reaching that threshold, it's on the developer to upgrade.
For capacity.
That's going to curb a lot of this where the developer, we're gonna say, well, you have to upgrade everything downstream of your tying point. Well, that could be $1 million. If your development's viable to you, you're not gonna negatively impact everyone else. So there are ways to do it, but once we go this sewer route, the state of Georgia requires, so say we can't get the city of Griffin to come to an agreement with us and we go down our own treatment plant road. Once we hit that 80% capacity threshold, we have to put a design in place with the state, or the Board of Commission and the development is gonna have to say, we can't allow any new development. Well, that's essentially doing a moratorium. So we have to be very methodical on how we do this, because once we start, we're not gonna stop.
Well, that's the only thing I just want us to be
Yep.
aware of, that while it's great and we think we'll be able to do that, we will be so close to other properties that they will definitely start coming and asking. So as we plan, we just need to be aware that that can
This is
happen.
gonna, we start down this road, this will change what our county looks like and what the residents are in it. You know, and there's issues all the time we hear about, and not to beat this horse, we don't wanna be Henry County, and the way that looks in 155 and all of that stuff. And then we turn around and say, hey, are we getting ready to do exactly that same
Well,
thing?
I will say this, Henry County made a conscious decision to sewer the county.
Oh,
We're-
They had poor controls in place too.
That's right, we're not
that's my point.
interested in-
We have to walk down that control route and say, what does our county residents want?
I agree, but
And those have got to be
That's
hard policies that we think through, and there's lots of unintended consequences that we don't think, so.
let me just say this, most of that lies at the commission making land
Zoning,
use
yep.
and sticking to it and not giving in to every developer coming along. So that's your problem for another day.
Thank you.
Well, we got a lot of control over this.
Yeah, so,
We
All
said
right,
we're not gonna build a
but
sewer
we
system.
got Rebecca standing there running where we're going with this.
Question, would these different conveyance types have an effect on location of treatment facilities, being one being gravity, one being pressure? How does that, how do they affect that decision and siting of treatment sites?
He knows how I'm going to answer this. So, good question. The answer is that they could affect, but I wouldn't want them to affect. And here's my explanation. So low-pressure sewer doesn't mind going uphill. So, theoretically, you could then have the option to site your modular plant wherever's convenient. Maybe a developer's donating some land. That, and if you end up deciding you want to go that way, we can do that. But my logic is that, if we can keep the plant at a low elevation where it logically ought to be anyway, it just provides you with so much more flexibility in the future. If you go gravity, or imagine if you do expand in the future to the point that you are at LAS today, but eventually you want to go to a stream discharge. Well, you have that site, you have that land, you can convert that plant to a pump station, you've got the property and stuff's built up around it. You've got the land, it's in a perfect location, you're already receiving your flow there. Convert it to a pump station and pump to that new centralized plant, that NPDES, permit location. So, so the answer to your question is yes.
You want to think long-term initially.
Right. I mean, unless we just decide that that putting that plant at a technically not great location is going to last you 50-something years, and you're you don't expect to expand or grow or need to ever relocate to a centralized plant. If you end up giving me that feedback, and again we've got another workshop planned, so we'll get into that as well as your trigger point question. So, but I'm going to try to preserve, the option to put that plant at the best location to give you more options going forward, regardless of whether it's gravity.
Okay, and so based on your answer, it sounds like you're also going to have some gravity flow sewer in your system. It's not all going to be low pressure.
It
Correct?
could be a combination.
So you may have some I&I.
Again, it's
It's not all low pressure. Okay.
there's pros and cons to low pressure versus conventional.
I mean, you don't pump downhill, so
Generally not.
if you're putting it at the
Yeah.
lowest point, you're going to have some downhill runs.
Yeah. So, and again, this is low pressure. It could very well be, collecting from your network and then, discharge into a
Central
manhole,
plant.
a collection. That's just a stretch of gravity sewer just to get to the plant. That could make a lot of sense. But whether we split, AKB is an example. So, AKB is this corridor that has there's a low point right here. So, if you decide you can locate a plant there, and still you may have to cross a creek and have a pump station. There may be an incentive to where you have a couple different basins you're spanning to have one section of it be low pressure sewer that then conveys to a gravity network. Again, it's a bit of a complication, but and I can work out what I think is the best technical solution. If you tell me, hey, I'm interested in low pressure sewer, I want to consider it, and my driver's really cost, or let's make these boundaries smaller, let's serve these customers first, and so if you point me in the right direction, I'll lay out what I think is most suitable. So, and to the point too about your being within a couple 100 feet of a development, and or residents being a subdivision being able to connect, you're ultimately going to be writing a sewer use ordinance that's completely new to what you're doing here. I mean, because you're going to have policies on grease traps, and you're going to have a grease trap, fog program and things like that. Any kind of if you were to have any kind of industrial pretreatment in the event that something we're discharging that didn't meet spec. So there's a whole host of things that you're going to have to cover in a sewer use ordinance, and the connection for tapping, provisions for tapping in. That's just one of many things that you're going to have the opportunity and the obligation to make decisions on.
You touched on a question I have. Low-pressure sewer for industrial, heavy users, pretreatment, all that works still with low-pressure sewer or not?
It's no different than,
No different?
it's, the only caveat would be if an industrial user had a pretreatment system, their grinder pump station would be located after that.
Okay.
That's it. Yeah.
Okay, more questions for Rebecca?
Well, I have to make a comment. I feel like we're not headed in the right direction. Our first report was a whole lot of arithmetic that told us nothing, but I guess you can build from that, so I think we're going the right way.
Okay. Thank you.
Okay. Joseph, let's kind of, my intent is kind of end up with Joseph talking about what he's heard, what he wants us to understand out of Rebecca's briefing, and then go ahead and get out of here. Jim?
Second half
before-
sounds good.
Are we giving up on the 1941 corridor?
No, we just highlighted those two because it showed kind
Just
of
the
the
cost
variability
difference.
that we wanted to
Okay.
really highlight.
The highest and the lowest.
That's right, that's right. So every corridor is going to be assessed the same approach is going to be applied.
Okay.
Just a thought process to get us moving and to show us we're talking about modest stepping into doing sewer, not building Griffin's system for us. Okay?
I will say this, again, I go back, if Griffin expands Shoal Creek, as they're talking about, their line stops at pretty much the city limits on the north side. It would be easy to extend that line a little bit to pick up some
Cool.
folks. Those are little pieces,
Yes, I'm hoping that
without
we're,
opening to the county to,
I'm hoping we're gonna talk about some of that stuff, other ways of being able to do it, to say, all right, we're gonna go to Sun City and buy some capacity up there in the north portion. Here's how we're going to do it, I'm hoping we're gonna talk about all of those. What do we really wanna do out 16 West? Those are questions that we're gonna prioritize and try to see which ones are easiest, which ones can we bite off, So, all right, Joseph?
So the major things that we need to get some type of consensus on is, are we okay with making the approximate number of customers we're gonna serve roughly 500 homes, meaning 100,000 gallons a day? So to answer your question regarding what the industries look like, so the one on Tomachichi would literally be up to 40 homes. So it's not very big. So that kind of qualifies it. We use residences because it's easy to understand. You know what a house looks like. You can estimate, okay, well, Sun City is 3,600. So a smaller portion of that, we use residences because everybody kind of understands it. So is everybody okay with kind of that philosophy of saying, okay, we're going to use 100,000 gallons in each corridor? Because we have to have a number and a threshold.
Gotta start somewhere.
That's right. And remember, the goal is the modest means of entry.
So, we all it's a starting point, and once we get into it, we can decide to change it, but we gotta start somewhere, so let's take the first step, say 100,000, okay?
I have no better idea.
Okay?
Okay. And the low-pressure sewer is a viable option that we need to pursue. Is that correct? Because, I mean, yes, we understand that when we get down to the nuts and bolts, there will be more than likely a combination of low-pressure sewer and gravity.
But you still
But-
cut out some piping I&I issues.
That's
So you've
right.
lowered your cost of ownership over time.
Well,
You have
and
a smaller pipe.
Yep.
while it may be gravity, we could make the case to say, we're gonna keep it in the low-pressure pipe with the intent in year 10, when we hit this flow volume, or the metric, that we go and we change it from gravity from these 2 points. So I think when the study's done, we're gonna have an approach, we'll have a methodology, we'll have some basic levers that we'll need to keep in mind as we master plan the sewer infrastructure going forward.
Low
But-
pressure, first time I heard it was today.
Correct.
I didn't know anything about low pressure until today. So,
It's sent from me.
yeah, new information to,
They do use it in East Tennessee. I dealt with it. I didn't know it was actually called low-pressure sewer, but I know exactly what you're talking about.
okay. All right, next point.
And I think we all, at least it's my impression that based on what we saw today, there is a viable option that we can pursue. So I hope you are in the same agreement, but those were the 2 main points that we really needed to get confirmation on, because that's really going to allow us to take the next step with the city of Griffin, with any other municipality or sewer provider. Because if we say that, hey, we need 1.5 million gallons a day, they're gonna say, that's more than I'm currently permitted for right now. So that's all I had.
Here's just a thought process for you, for people to think through. There's a movement afoot to put casino at the raceway. Everybody should know that that's being tried up at the General Assembly. If that passes, the impact that's going to have on 1941 and us is absolutely astronomical. We will see all kinds of things start to happen if that turns into a casino. It will change the way we look at things and the prioritization we have. So there's lots of, okay, this looks really good out here. All of a sudden, a casino being put there will change everything that we're talking about on 1941. As we start talking about hotels, all that kind of stuff will just appear out of nowhere. We got to think through some of this, and part of this is just education in our mind. Low pressure sewer, oh, that's a way of doing business. Here's how we can do the sewer business, so that we could turn around and just simply say, all right, we're not going to do Arthur K. Bolton, we're going to do 1941, and this is what we're going to put up there to be able to do it. So just the process is getting your mind wrapped around the whole bigger issue. All right.
Let me ask you guys one more question. So, Rebecca and Joseph, in coming up with these plans that will eventually come back to us, I know we've talked about looking at doing any kind of work we can with the city of Griffin, but are we also looking at the other counties that are contiguous to us? Henry on the north side, but out on the further end of the industrial park. Anytime that we don't have to build infrastructure and maintain it will be a plus if somebody's got to run a system if that happens.
So Rebecca and I have had this conversation, and we are working on getting a meeting with the city of Sonoya in the first part of May. Rebecca reached out to Butts County Water Authority just to see about setting up a meeting, and they basically told her that while there's nothing saying that you're not allowed to, that we won't work with you, typically if you're not 80% of the project is not inside Butts County, that they're not gonna have any ambition on doing anything. And kinda our philosophy is, and correct me if I'm wrong, but if we're gonna spend money to upgrade infrastructure, is it the board's understanding that we would wanna upgrade infrastructure inside our county lines? So I think when we look at the costs, we'll bring everything back to the board and let y'all make the decision. But yes, we are working with other municipalities. I just don't know how receptive they're gonna be. Because
Okay.
Butts County, unless the project's there, we're not doing it.
Let me make this comment. I don't know, I don't think most people, I got the paperwork from a study goes back 30, 40 years, whatever it was. When Henry County built the sewer plant up at the racetrack, that area, they offered Spalding County the option to tie onto that. There was a whole project. Of course, that's uphill, you have to pump it, but they offered the sewer 1941 coming down from, and the county time said, they don't need no stinking sewer.
Okay.
But
So-
it's available, or was then.
I don't think it's available. You're talking about Bear Creek, and I don't believe they got any capacity left.
I beg your pardon?
You're talking about Bear Creek.
Yeah.
And I don't believe they have any capacity left.
No, I think they filled it up probably.
So,
But those things are out there.
and we've got to think through them and be able to take each one of them and say, the best way is not build, it's just buy capacity and we'll run the pipe over there, or however, no matter what it is. So we're going to have a lot of time to work through those thought processes, but we've got to start thinking through them and working along. But, all right. Anything else?
That's it.
All right, anything from the board members? All right, do I have a motion to adjourn?
You do.
Second?
Second.
All those in favor signify by raising your hand. We're adjourned. Well done, Rebecca. Thank you.